Let's make the next step towards your model. In this lesson, our aim is to introduce the fundamentals of importing time series data, analyzing it, forecasting future trends, and visualizing the outcomes. Let's start with reading data. R supports various data formats. We will dive into Excel and CSV files. First, ensure that the files you want to read are downloaded onto your computer. To read an Excel file, you'll use read_Excel and specify the file path as shown with the actual location where your Excel file is saved. Use slashes or double backslashes when writing the path to navigate folders. For CSV files, it's similar. Take a look on my screen for the example. Now, we need to convert data for the time series analysis. We need to ensure that numeric data is recognized as numeric by R, so we'll convert it if necessary. After that, we'll create a time series object for selected variables. Let's see how this process looks in our example. We identified two time series data in the set, freight carried and freight turnover. The autoplot function, when applied to the respective time series objects, creates graphical representations of the data where the y-axis represents appropriate time series, while the x-axis represents year. The visualizations appear in the plot area and provide first insights into the trends in developed time series. Here I suggest to use summary function that provides you a quick statistical summary, including minimal and maximum values, mean, median, and quartile values, offering a snapshot of the data's distribution. The ACF function in R helps us see how much each point in a list relates to the ones before it. When we apply ACF, it shows a graph. This graph tells us how connected each point is to the ones that came before it, but at different distances. Here we can see that at smaller lags, the bars on the autocorrelation plot are very tall and then fall inside the blue lines as the lags increase. It indicates a strong short-term relationship that weakens as the time lag increases. The forecast function within the forecast package is a valuable tool for generating predictions based on historical time series data for the specified future time points. It automatically selects suitable forecasting methods, adapting to the properties found in the input time series data. The blue line in the forecast plot represents the predicted values. The gray area surrounding the blue line in the plot represents this range, showcasing the level of uncertainty associated with the forecasted values. In R, different forecasting models are available. We'll focus on 3. ARIMA combines components for diverse data. ETS captures trends and seasonality. STL decomposes time series. AIC helps pick the best. Let's explore. Initially, I fitted 2 models and acquired forecasts, excluding STL due to its focus on modeling seasonality. Next, I computed AIC values for each model and directed R to select the one with the lowest AIC. Lastly, I instructed with the code to showcase the best model, revealing both the AIC criterion value and a graph displaying forecasted values. Let's display the outcomes of our time series analysis on a graph. Firstly, we'll plot the initial time series data alongside the forecast. Then, we'll introduce the ARIMA forecast, distinguishing the model data in red and adding a custom label. Following that, we'll include a legend for better understanding. Next, we'll emphasize the forecasted region, marking the conclusion of observed data. We'll then label the axes for clear representation. Additionally, we'll highlight the maximum, minimum, and mean values. Now, with all the analyzed observations on a single page, we can gain a comprehensive view of the data. This is what I would like to deliver for you about basics of time series analysis, forecasting, and visualization. Now I are your time to practice.